Hello students, how are you? Today we will start from the system of units again. We will introduce you about how to convert one form of system of units into another form. I earlier told that basically there are two types of system of units. One is SI unit and another is CGS unit. SI unit stands for System International and CGS unit stands for centimeter, gram and second. So we will start how to convert SI unit into CGS unit. Now we will understand to convert SI unit into CGS unit from some example. For example, I want to convert the SI unit of velocity into CGS unit. Here SI unit of velocity is meter per second, that is meter by second. Okay, now all of you know that in 1 meter there is 100 centimeter and in 1 second the second is already written as second in CGS form. So SI unit CGS unit for velocity is 100 centimeter divided by second, that will become 100 centimeter per second. This is the CGS form. Now come for another example that is related to force. In your previous class you have perhaps seen the formula for force. Force is equal to mass into acceleration. All of you know that SI unit of mass is 1 kg, SI unit of acceleration is 1 meter per second square. In 1 kg there is 1000 gram and in 1 meter there is 100 centimeter. So it will become 10 to the power 5 gram centimeter per second square. That is also known as dyne. Here we will use some notation that will be used again and again in this chapter. For instance, first one is distance or displacement, that is denoted by S, time, that is denoted by T, speed or velocity, that is denoted by V, initial speed or velocity, that is denoted by U, final speed or velocity, that is denoted by V, acceleration is denoted by A, acceleration due to gravity is denoted by G. I have not given the vector sign here because we have not seen the vector and scalar quantity. Here some of the quantities are vector quantity. For example, displacement. In case of displacement, there we will use the arrow here. In case of velocity, we will use the arrow here. Wherever the vector quantity, we will use the arrow. Now come to the types of physical quantities. Broadly, all the quantities in physics are divided into two types. One is vector quantity, another is scalar quantity. For your class, only two types. In higher class, it is of three types. That is also known as tensor quantity. That is not given in our syllabus. In higher classes it is, perhaps your graduation, etc. So we will not concentrate on that one. Now, example of the vector quantity is displacement, velocity, acceleration, force, linear momentum, acceleration due to gravity, weight. All these quantities have magnitude as well as direction also. Now in scalar quantity there is mass, length, distance, time, speed, temperature, work done, energy, power. Remember students, you try to mug up all these examples. That will be very much useful for you for your examination point of view. Now we will be coming on the definition part of vector quantity. Vector quantities are those quantities having both magnitude and direction. It has to follow the law of vector addition. That is the essential condition for a quantity to be the vector quantity. Scalar quantity has only the magnitude. Okay,